Okay, hello everyone. This is Jenny. I'm hosting today's session for the CICS, and welcome to this session. This session will be delivered by my colleague Mark Lawrence, who also work in the CICS development at Hursley Lab in Winchester, UK. Mark will bring you the new features from the newly announced CICS 6.2 around security. So over to you, Mark.
Thanks, Jenny. Can you hear me? Good
Yep.
start. Right, okay. My name's Mark Lawrence. I'm a software engineer for the security team in CICS in Hursley. And I'm going to be talking through a bit about security definition capture and validation, two new offerings which we'll be bringing in 6.2. There's quite a bit of content and there's going to be a few risky live demos demonstrated throughout. So I'll probably try and nip through everything with Q&As at the end if that's possible. Right, so before I crack into talking about those offerings, let's talk about why I'm even talking about them. So part of what CICS Security wanted to offer customers with 6.2 is tooling to help them implement a zero trust strategy. So that's allowing the right user to have the right access to the right data for the right reasons. So typically, people might access a system using a username and password, and once you've got access to that system, you've got access to absolutely everything, right? And what we're really trying to do with zero trust is we're trying to provide authentication and verification on the actual time resources are used. So all of your data, all of your files, they're now going to be authenticated and verified before they're accessed. So we're talking about protecting the resources and not just system boundaries. And because we're wanting to implement this, we don't want to ever trust anyone who's automatically in the system. So we're always validating and we're always assuming that bad actors are already present. So we're continuously doing this. So every time a file's accessed, there's going to be a check to ensure that that user is allowed to access that file and with the correct permissions. So the problem we've got is typically customers have only really switched on transaction security, which in effect is a form of boundary or a perimeter checking. So you've got security checking on the transaction, but once you've got into that transaction, all resources are fair game and you can access all of them. So what we're really trying to say is, well, you get the transaction security, but we want to try and offer you tooling to allow you to switch on resource security and command security. So you get past the transaction, but then every single resource and every single command has a security check on them as well. Now, the trouble with switching on resource security and command security is that it's very expensive. You can't just switch it on because the permissions might not be there in the database. And if you try and put something together, you might find that all your applications start breaking because you've missed out certain permissions here and there. A lot of customers don't already have automated testing to run after you've switched them on to ensure everything still works. And the data's vast because you're working with a security database with thousands of users and thousands of permissions. And what we found from the CICS Architecture Forum back in 2022, I think it was, we found that most customers have been dealing with users and permissions on an ad hoc basis. So a developer might introduce a new feature which accesses a particular file and they'll send an email to the security admin and the security admin will switch on that permission for that user and that's it. And then typically when people leave, the permissions are not revoked. And over time, that just basically gets your security database into quite an unmanageable state and nothing's really consistent throughout. So you end up getting into a position where no one really knows what the security is within your security database. It's there, it works, don't touch it. So what we're trying to do is we're trying to give you tooling to allow you to switch on RecSec always and Command Sec always. And to do that, we've got a feature coming in 6.2 called Security Discovery. And what that is a tool to enable you to switch on resource security. So you would switch on security discovery and it will monitor your production system for a period, a month, a couple of months, and it will log all the security accesses over that period. So all users, all of the resources which they access, what level of permission they're using. And then after that period, we then stick it through an algorithm, which then starts working out, well, okay, let's group these users up here because they've got similar permissions on particular resources, and then we'll group up this bunch of users here because they use a particular bunch of resources. And what we'll actually do is we'll end up building up roles. So we've got groups of users, so we can say, right, okay, well, here's a role. These look like our admin people. These look like our teller people. So we'll create a teller role with all of these resource accesses here. And we're basically building up your security definitions for you. So instead of having a big sea of users and permissions, you'll actually start getting a much more smaller number of roles, which is far more manageable. And at the end of this, once it's all done, the tool will actually kick out some RACF definitions, which you can actually run. So it's helping you move to resource security there. This then presents a new problem. So now you've got your far more manageable security model in place. How do you then ensure that the model's kept current efficiently and is not incorrectly or possibly maliciously changed at any point? So the solution to that is introducing the testing of your security definitions into your existing testing practices. So what we're offering for 6.2 is two things: security definition capture, which we call SDC, which allows you to capture security usage when you're doing manual terminal testing on a 3270 or API testing over an HTTP interface. And we're also offering security definition validation, which is a collection of tools which allows you to automate SDC and then validation of what's been captured within a continuous integration pipeline. So I'm going to deep dive into each of these now. So first one I'm going to look at is security definition capture. So what is it? So this is tooling to allow the manual capture of security accesses witnessed during a user-defined period. So it's got two interfaces to switch it on. We've got a CXSD transaction for when you're running manual tests over 3270. And then we've got HTTP endpoints to turn on CSD for when you're running API testing. Then we provide the output of that is YAML. So in your YAML, it will show you all of the security accesses used within the defined period of when SDC was switched on. And the idea is that a developer, before they make an application change, what they will do is they will run SDC on their program before they make the change. You will then get some security metadata out of that, and you will call that your baseline security metadata. Once you've captured that, the developer will then make his application change. Then he will run the same test which he ran before and switch SDC on, run the same test as before, and then the output will then be the new security metadata following the application change. And then the idea is that the developer can then compare the two outputs to see if there are any deltas. And if there are any deltas, that's when they should then contact their system programmers or security admins to then say, can you check this over? Are you happy implementing these security changes on the security database? Now, I've just given an example then of a developer doing the comparing, but you could also set up SCD to actually send the reports not to the developer, but immediately to the security admin, and they can be alerted, and then they can do the comparisons so they know what's going on without the developer having to send emails around and contacting them. There's nothing really special that needs to be in place to run SDC. It just simply needs security to be switched on so that you can log in as particular users. And therefore it can run on developer systems. No special security needs to be set up. So why would we use SDC? So it can identify known and unforeseen desired changes to security by developer and their changes to the application before the code is actually delivered. So you're highlighting these issues as far left into the pipeline as possible, rather than finding out later, which is when it becomes a bit more costly. From the CAF, the CICS Architecture Forum back in 2022, we found from the research that many customers are only really doing security testing at pre-production and onwards. So starting to do it much more further left in the pipeline is bringing your security much earlier into your development processes. So rather than it being pre-production, you're actually doing it before the code's even delivered. So that's going to help out any kind of zero trust strategy you want to implement. It simplifies the process of getting the security right, and you can do it right now because you don't need any infrastructure to do this. So currently, it's giving you the tooling to actually identify changes in security using human readable YAML, which you can then pass on to the security admin. It makes it a lot easier than however it's done currently. It can help towards identifying unwanted security changes. So a developer might find that there's an unforeseen change in security by what they've done, and then liaising with the security admin, then they can work out, well, it shouldn't be doing that anyway. Let's change your code so it doesn't do it. So you can actually find that out. But obviously it's a manual process. It's not enforcing it. So it's still manual. Providing that developers are going to do this and they're going to run SDC, you'll get that benefit. And another benefit to this is that SDC can be introduced into any form of existing testing you may currently have. It's literally a case of just changing how your developer would run the test. They just have to simply do a baseline, run CXSD or run the HTTP endpoint, and then they get the SDC capture. So just going through the flow, I'll brush through this because I think I've more or less covered it already. But if a developer is changing the code, they would make the code change, compile it. The developer would then start SDC using HTTP or using the CXSD transaction. The developer would then drive the manual test. They would then stop SDC. SDC will automatically run a YAML generation job to generate the security metadata, which is happening here. Step 5, the dev can review the job output, or it could be sent to the security admin. If there is a change in the security, then the developer can raise a request to security admin to get the changes made to the security database. The security admin can then review those changes and make the changes, implement them on the security database, and then you're then allowed to go and deliver your code. So here's an example of the security metadata which you get out of running SDC. We can see here as an example, the ones highlighted in red, we can see that we've got a file resource class being used here, and in particular, the file name was called file A, and user U125 is reading it. So we can see there that it's very human readable. It's all very clear what's going on. And we'll see a few more examples of these later. In fact, we'll see them right now, because this is the time when I'm going to try and attempt to do a live demo of CXSD. So this is IDZ, IBM Developer for Z. Down here, I've got a connection to a Plex, which we've got in Hursley. I've got a list of my jobs. I've got 3 CICS regions running and a couple of old jobs here. And I've got a couple of data sets here. The main one to know is I've got this mlawr.test.load. That's basically a library which I use to compile COBOL programs to. And that's been defined in a particular CICS region, which I'm going to use as part of this demo. So it already knows about that location. And then I've got a data set here, which is where I store all my COBOL code. So I've got one in here called CXSD test.cobol. So I'll open that up. Here we go. So this is a genuine COBOL program. I think what it's doing is it's doing some outputting some debug to a TDQ somewhere. It's calling a function remote check, and that goes and calls an external program which returns a list of all of the most recently applied PTFs onto the CICS region. And I think my program picks out the top 5 and returns them. And this is what would output in the terminal when the program is successfully ran. CXSD test pass. So that's what my program's doing there. If I then bring in over a 3270 emulator terminal connection program here, so I can log on to this particular CICS region. So I'm in now. I'm going to log in as me. Copy my password from somewhere. So I'm in here. And this program, CXSD test, I've actually got a predefined a transaction called MJL1, which will call this program. If I run that now, I'm getting CXSD test pass, which is that text there. Okay, so the program works. So I've got a work item that's telling me, right, I need you to implement a new feature into this program. So before I make that change, I'm going to take my baseline. So I'm going to go back to this terminal. I'm going to do a CXSD on. STC has been switched on. So right now it's going to be recording all security accesses made whilst I'm in the terminal. I'm going to run my transaction, NJL1. That successfully ran. I've got my CXSD test pass up. And now I'm going to turn SDC off. We're running CXSD off. That's switched off now, and it's automatically submitted a job, and it's done it to me, not to a security admin. So that's how I've got it configured. So now I'm going to use IDZ to actually look at my job list, because I'm too scared to do it through ISPF. And I can now open this job up, and I can see that there's a bit of YAML in the output, and that was ran 148, which was, well, 30 seconds ago. I can copy this, and I'm going to stick it into a slightly nicer text editor. There we go. So there's some security stuff in here. I don't really know half of what it's doing, but I know that down here there's a transaction that's called, and it's my MJL1, and the user mlawr, who I logged in as on the terminal, has got read access to it. So I know that this marries up to exactly what's just happened on my terminal. So I've got this now. That's my baseline. That's before any code changes. So now what I'm going to do is, in this COBOL, I've got a bit of commented out code here. So I'm going to uncomment that, save it. And what this is doing is it's adding a bit of output to the debug output to a TDQ. Then it's doing a CICS inquire on the system, and it's trying to access the default user. And there's nothing else in here that does anything like that, like inquiring on system properties. So that's in there. I've saved the COBOL. I'm then going to run a job which I've got somewhere else on the Plex, which compiles that COBOL and sticks it into my test program library. So I'm just going to run that. There we go. That's completed. So that should be compiled now. And what I'm going to do in my CICS region is I'm going to run CEMT set program. So because the program's cached in CICS, I'm now running this program to say, right, there's a new copy of this program now. So flush out whatever you've got it in your cache and then load in the program brand new. That's run successfully. Lovely stuff. I'm going to clear my terminal. And now what I'm going to do is I'm going to run that same test which I did before. So I'm going to do a CXSD on. That's now on. I'm going to run NJL1. Fantastic. That's run successfully. And then I'm going to do CXSD off. Right, that's SDC turned off now and a new job's been submitted. So if I go back to my job list over here, refresh it, I've got a new job down here. There's some YAML in the output. If I open that up, and I'm going to copy that and put it back into my nicer text editor again. That's in. So now it's just a case of comparing. So if I do an F1, VS Code allows me to compare with this quite easily. So this is the differences between the two. So I can see, let me expand this. So the time's different for starters. One was run on 148 and the other one was run on run 51. That's fully expected. Everything's the same here, but we can see there's a brand new security definition in here. And we've got a command being called, which accesses, it's a system command, and user mlawr is trying to read it. So the developer should now package this up, send it to the security admin and see if there are any issues with that. And if there are, then there can obviously be some kind of approval or conversation that goes on about this. But that's highlighting that here and now, and that's something which you can do as part of your manual testing now. That's all I wanted to demonstrate for CXSD. So I'll do it. Go back to where I was. Right, that's the demo. So next, so that's the CXSD 3270 terminal. We've also got the other offering, which runs on HTTP, which is exactly the same flow as CXSD, but it's just using a different interface to turn SDC on and off. So we've got a couple of HTTP endpoints. We've got a get, a post, and a delete, which I'll demonstrate in a minute. And then the same as CXSD, once you stop the SDC, it will fire off a job automatically, and your security YAML will be available in a job which has just been ran. And you'll be able to access it via that. So we're now going to demonstrate HTTP. So what I've got here is HTTPIE. So this is like similar to programs like Postman, where you can basically, it allows you to test and interact with REST APIs and things like that. So I can define gets on particular URLs, I can fire them off, and then I can fire off posts, etc. So what this can do is we're pointing to a particular URL, which is rplex, and a particular port, which is a TCP IP service, which is going to be pointing to a particular URL, which our SDC program responds to and is listening on. So if I run a get on it right now, it's telling me that SDC is not switched on, right? Now, one of the things that's going on is I've got an authentication header in here, right? And this is HTTP is telling me that this is inherited from the collection, and the collection is just the parent thing that's holding all of my endpoint calls. So it's doing basic authentication using the user mlawr, right? So when I call get, it's actually trying to see if the user mlawr is running an SDC on whatever CICS region is responding to this URL. And at the moment, there's nothing going on, right? So If I run a post, I can start SDC. So I get a 201 response and I get a message saying SDC has been switched on. Now, it's actually the same CICS region which I did my terminal demo on a minute ago. So I can actually run MJL1 on here. And I've got my CXSD pass. And what I can now do is using HTTP, I can run a delete and then send that over the API, and that's stopped SDC and it's submitted the job. So you can start and stop on HTTP, and anything which that user does on the CICS region will be recorded. It doesn't matter whether it's over HTTP or whether it's on terminal still, everything will be recorded, whatever they do on that region. So if I go back over to my job list over here, I've got another job here, and hopefully this will be YAML, which is being collected at 156, which is, we're on 156 at the moment, and we can see that it's running the same command. It's notice I've run MJL1 and it's mlaw with read access, and it's got that command thing on there because that was the last change which I made to that program. I included that system command. So that's demoing it using it over HTTP as well. And that's all I wanted to demo for that. So I'll continue with my presentation slides. So now I'm going to start talking a bit more about SDV, Security Definition Validation. So what's that? So it's an example implementation of a full continuous integration pipeline that uses SDC, what I've just demonstrated, within the automated testing stage. And if it finds any kind of change to the security as part of the automated testing, it will initiate an approval process, which must be successfully completed. So in most SCMs, I mean, GitHub's an example, Bitbucket's another one. If you want to make an application code change, you have to open something called a pull request. They might be called other things in other SCMs, but essentially it is a quality gate so that before you deliver code in the SCM, you can do code reviews X, Y, and Z. And what our demonstration will do is it's going to actually block these requests for code changes until any security deltas have been approved by an authority, which would be a system programmer or a security admin. Why would you do it? For the same reasons why you would do SDC. So that's identifying developer changes to security early in the development lifecycle. You're obviously testing security before code goes in, again, rather than leaving it much later in the process. You're also providing an unbreakable quality gate, which is actually owned by the security admins against developer code changes. So if they're trying to do dodgy stuff hidden within their code, accessing files they shouldn't be able to access, it's blocked. The quality gate's blocked. It's not going to get through until the security admin has actually approved it within these tools, which is part of your continuous integration pipeline, and it's blocked, so it won't get in. By using these tools and it being part of a continuous integration pipeline, it's actually going to speed up the process of getting security changes made, because a tool's automatically finding the changes and it's automatically creating the approval process for the security admin. It's giving them email notifications to say, look, we've just created this, can you have a look at this, rather than it being clunky emails and being chased up through phone calls and things like that. It's all being done automatically as part of the pipeline, and it's blocking stuff as it goes through as well. So there's a lot of quality going into it and a lot of speed. It's obviously all automatically done, which we've kind of just covered. It also stops unwanted security changes making it into the code base, and it's enforcing it. So if a developer's doing something that's undesired, there's absolutely no way it's going to go into the code base at all. They can't kind of sweep it under the rug. It's being done automatically as part of automated testing, which is running on every single request for code changes on that repository. And of course, if you're implementing something like this, it contributes towards a greater DevSecOps goal. So that's kind of like a big strategy, a big idea kind of thing, is introducing security to every part of your DevOps pipeline. And this is obviously just testing security on CICS application changes. So it's helping towards it, but it's not the big picture, but it's helping you achieve it. So how do you do it? So in my example, yeah, we're gonna be using a lot of IBM approved tools for this. So we're going to be using GitHub for source code management, which is making use of webhooks, pull request checks. Then we're going to be using a tool called Tecton, which is kind of like our version of Jenkins. It's a CI tool, and we're going to be using Galassa, which is our automated testing tool. But we are using these tools, but it's completely achievable using other CI pipeline tools. So what we're going to be doing is, yeah, we're going to be demonstrating what we've done in Galassa to make this possible. We then had to do some Ansible scripts to make the security checking possible, and we've written a GitHub app, but all of it's going to be open source. It's not going to be part of the CICS product, but it's going to be something open source which you can go and reuse. Or if you don't use these particular toolings, you can go in, see the code, and implement it in your own toolings. So just a quick breeze through the flow, because I'm going to demonstrate it anyway, but it's much the same as CXSD. A request for changing the application code goes in, the code is compiled, then we have this cyclic loop of your automated tests running before and after. It stops SDC, it starts SDC, and it stops SDC. And after each one, at the end of it all, it will then submit a job to generate the security metadata. Then we have a bit of code, which then compares a baseline with the new security metadata that's come out of automated testing. If the tool notices that there's a delta, it will automatically create a request for change on the security metadata against the security admin, which then they've got to approve. And if they reject it, it will be blocked. And then the developer will be known as to why. And then if they do approve it, then everything gets unblocked. And then the code change at step one is allowed to go into the code base. So this is an overall architecture of what I'm about to demonstrate. So there's a lot of stuff in here, which is, again, IBM specific. We've got a lot of GitHub. We've got about 5 GitHub repositories around here. We've got a build process that's using Tecton. But again, it's the tools which we're allowed to use in IBM. You can use Jenkins for this. You can use Bitbucket for this. You can use SVS for this, CVS for this. But everything which you can see in green, that's what's going to be open source. And that's basically where all the magic happens anyway. So we've got some stuff within Galassa, which is going to switch SDC on, and then it's going to run the job to get the security YAML and install the security YAML as part of the test run artifacts. Then we've got an Ansible script, which will actually do all of the security delta checkings, and then we'll create all of the approval process if it finds any deltas. And then we've got this tool called the approval bot, which acts, it's a bit of a bells and whistles thing, and it acts as like the go-between between the request for code change pull request and then the security change pull request. And then it basically keeps them in sync. So when one action happens on one, it will then change the status of the other one based on what's happening in real time. So I'm going to demo this now. So strap yourselves in. Hopefully it will work. If it doesn't, I've got a backup video, but I don't want to use that. I don't want to use that. Minimize this, minimize that. So this is GitHub. and we're looking at the CICS SDV organization. So let's pretend that this is your bank, a bank's organization or an insurance um, source code repository, and it's got all their applications in there. So what we've got in here is we've got a repository called application code, and that stores all of our COBOL, which does lots of magical things that makes the bank work. Then we've got another repository where we store all of our automated tests. We've got another repository called application security, and this is a new repository as part of the SDV process. This is essentially where we store all our baseline security metadata. So it's all stored in a GitHub repository. And then we've additionally got a repository where we store all of our infrastructure stuff. So this is where we define all of our CI pipeline, and it's all done in YAML for Tecton, but for Jenkins, it would be like Jenkins files, Groovy files, stuff like that. And then we've got the code for our approval bot, which is that application that acts as the sync between the two PRs. So let's have a bit of a deep dive into the application code, the tests, and the security. So application code, there's a bit of boilerplate stuff in here, but the main thing to note is that there's a folder called programs, and in here there's a bit of COBOL called SDV test. So if I open that, what we'll actually find is it's the same COBOL program which I used in the CXSD demo earlier, just that instead of CXSD test passing as its output, it's actually going to output SDV test pass. So again, this just basically calls an external program, gets a list of the latest PTFs and presents them to the user. Nothing really special going on in there at the moment. This is our Galassa test repository. So I'll just quickly have a dive into the tests and explain what we can see in them. So we've got 3 test classes here. They all do something different. They all use different users, and they use a mixture of different CICS regions. So this is test class 1 here. It's all in Java. There's a bunch of stuff in here, and it's essentially calling CEDA. That's what it's doing. It looks like it's allowing a teller to call CEDA, admin to call CEDA, and operator to call CEDA. But the key bit of magic that makes all of this work is an annotation we've got here called SDV user. Now, what this does is it ties into a manager which I've written for Galassa called the SDV manager. And what that will do is it will say, right, okay, well, get me a user and then assign it to this variable here. So this variable here will be assigned a user with a username and password, and then you can use that throughout your test. We provide it a few parameters here. So we provide it with the tag of the CICS region that user is going to run on, and we also provide it with a role tag. So here we've got 3 users, user 1, 2, and 3, and they're all pointing to the same CICS region, but they've got different role tags, R1, R2, R3. Now, there's a bit of magic in Galassa where you can actually use these arbitrary strings and then map them to actual values you want to use within properties, Galassa properties. So R1 actually maps to something. Now, usually you set them up in Galassa over a command line interface. But what you can also do is within our repository, you can actually provide a properties override file when you run the tests to say whatever properties you've got in your system right now, override them with the ones which I've got in this file. So we can see here, we've actually got role tag R1, R2, and R3, and they're being assigned teller, admin, and operator. So our tests here, that's going to be a teller, that's going to be an admin, and that's going to be an operator. So another bit of magic that's going on in the scenes here is that these users are already predefined. So on our ZEOS system, I've actually created a bunch of tellers already, and I've already assigned all of their permissions, and I've created about 3 of them, as well as I've created about 2 admins and 2 users that are set up with operator permissions. And what we've also got in this SDV manager is it will actually pick that role from a pool of roles. So in the properties here, I've set up, okay, well, on this ZEOS image here, for the teller role, I'm going to provide you with all of these credentials here. So we've got 3 users. Now, SDV user 1, 4, and 7, they actually map to usernames and password credentials, which is set up somewhere else in Galassa. But essentially here, I'm telling the SDV manager, right, okay, if you've got a teller, there's 3 possible users you can pick from. If you've got admin, there's 2. If there's operator, there's another 2. So when Galassa is running, it will try and pick from that pool, and once it's picked a user, it will then mark it as in, like it's active, it's in use. So any other test that's running won't be given that user, and you'll have to wait until the test releases the user until another test can use it. So you've got the option of running 3 teller tests in parallel at one time. Reason you've got to do that is if you're doing an SDC and suddenly the user's doing more than you expect, you're going to get a lot of noise in your security metadata that's being returned. And then another reason for putting in an arbitrary string, rather than just writing teller, admin, and operator within the test, if you use an arbitrary string, you might have a suite of tests with 200 test cases in there, and they all use teller. Then all of a sudden you decide, right, okay, well, actually, I want to see how they operate, how they behave under operator. So without changing the tests, you can actually go into the properties and actually say, right, okay, I want to change R1 to operator. And then you can run all of your Galassa tests as a completely different user without changing any of your test code. So we've done it for that reason. So just going through what each of these tests do. So this one uses 3 users, logs onto particular terminals, and then it makes a couple of CIDR calls. So that's test class 1. Test class 2, similar thing, but it's on a different CICS region. There's 3 users, and they're logging into a terminal, and the admin is putting something on a TSQ, and the TSQ is called GT11, and I believe the teller's reading that queue. And that's what that test's doing. And then test class 4, there's just 1 user here on one particular CICS region, but the things to note is that this test is defining a library, and then it's also defining a program, and it's also defining a transaction before any of the tests run. And if we look at this program, it's called SDV test, which is the same name as the COBOL code which we had in that repository which I just showed you a minute ago. And then it's going to, this transaction SDV1 is going to call that program SDV test. And then we'll see down here when we actually get into running the tests on a terminal, a user is calling SDV1, and it's expecting to see SDV test pass in the return on the terminal. Okay, so that's the tests. Now this is the application security repository. So if we have a quick look at this, this is where we store, this is like our silo of all the security metadata. So we have 3 test cases in our Galassa test repository, and you'll find that we've got a one-to-one mapping of each test case to a security metadata YAML in this repository. So if we open each of these up, we'll see that test class 1, remember there was 3 users logging in, and they were all doing CIDR transactions, just running and getting a return from a CIDR. So that's all been captured before. So that's essentially our baseline for that test. For test class 2, you remember it was the same kind of thing, 3 users on a different CICS region, and they were doing TSQ work on a TSQ called GT11, And there we've got the update, the admin was updating it and the teller was reading it. So we've got that all defined in security metadata there. And then test class 4, that was our one where we were calling a COBOL program, which was going off and it was getting a list of PTFs, wasn't it? All the recent PTFs. So that's been ran. And we can see here, not much to see, but there's a sea of security going on in here. I don't really know what much of it's about, but the main thing I can see is that there's a transaction, an SDV1 is being called, and that's that transaction which I ran in test class 4, which I demonstrated to you a minute ago. So the key thing with application security is that this is the security admin's repository. They own it, right? They're set as code owners on all of the files. So if I go into GitHub, there's a shield in there that says that it's owned by a team called security admin. And GitHub allows you to put branch protection. So if anyone creates a pull request or a request for code changes, you can set up branch protection to say, right, okay, well, I don't want anything to be merged in unless a code owner for this repository has approved it. So there's no way anything's getting into this repository without a security admin approving it. So we're making use of the features which GitHub provide. Yeah, okay, just checking my notes. So yeah, let's try this out. Let's try this out. Let's do a demo of it. Try it out. So I'm going to open the code and I'm going to open the security repository. I'm going to do them split screen. Right. Okay, so again, on the left, that's the application code. That's your COBOL. On the right, that's your security metadata. So the left is the developer's view. On the right, it's the security admin's view. That's what they see in the process. So I've got VS Code open over here. So I've opened this up, and what I'm looking at now is VS Code, and it's pointing to a local clone of the application code repository. So this is on my local machine now. And if I extend that, I can see my SDV test COBOL. There it is. So that's exactly what we can see over there up on GitHub. You see, there's my COBOL, and it returns the last 5 PTFs. And what I'm going to do is I'm going to uncomment this code. Same as before from the other demo. We're now introducing a CICS inquiry on the system to return a default user. So I'm going to create a branch to do this check on. Now I'm doing a git push, which is now pushing my local code change up to the GitHub server. So hopefully on the left-hand side, it will all kick into life in a minute. There we go. As I moved it, you can see that we've now got this banner. So GitHub's noticed that there's a new branch and I own it. So it's offering me the opportunity to compare what's on that branch on my own developer's branch against what's on main. So we can see here, I've made a commit and I'm actually uncommenting this code and I'm introducing the system command. So what I'm going to do is I'm going to create a pull request now to request that this code change goes into the development stream. So what can I see here? So as a developer, I'll create that pull request. I can immediately see it's blocked. I'm not allowed to do anything because required statuses must pass before merging. Now, if I have a look around, here we go. There's a required status called security required. So nothing's allowed to go in until this security check is approved and it goes green and it passes, right? So everything's blocked. You could add other blocks on here, like getting more people to review it, things like that. You can add a whole host of things on here to block this PR going in before it's allowed to. But I've just set up that this security test has to pass here. So a bunch of other checks have shown up whilst I've been talking. This is basically starting off a standard DevOps process. So it's cloning a bunch of repositories it needs in order to build and do its pipeline. It's going to build the COBOL. It's then going to deploy it on a Plex somewhere. Then it's going to run our Glasser automated tests. Before it does any of that, it's actually going to put a lease on the Plex to say, right, okay, because I'm making changes to an application on that Plex, I'm going to block all other tests from using it so that your particular change isn't going to be affected, or it's not going to affect any other testing that's going on. It's only this test that's going to run in that particular time. Now, if everything passes and the tests pass, it's then going to be passed over to this security check, which is then going to suck all of the security YAML out of all of the Glasser tests that have recently ran as part of this pipeline. It's then going to compare it against the baseline YAML, which we've got in that security repository, which we've got on the right-hand side. And if it does find any changes, it's going to create a pull request on the application security repository, which is then going to alert the security admin that as someone's trying to deliver a code change and it's going to change security definitions. So you've got to approve this and reject it, otherwise this code's not going in. So that process is going to take a while. It's going to take, 10 minutes to go through this because there's only a couple of tests. So what I've done is I've prepared a pull request earlier. So over here, it's the same change. So if we have a look at this, there you go. So I've created the same change previously a couple of hours ago today, called the branch blue, Peter. Fantastic. And then it's basically doing an inquire system default user. So if we have a look, all the tests have passed, including the testing. So even though functionally what the developer's done has caused all of the tests to pass because nothing functionally has changed. So the tests have passed. But the security testing has found that they've introduced basically a system command, right? So it's now blocked, right? And we can see, the developer can see it's awaiting full approval of the security PR. So if we go into the details, we can see, right, okay, it's blocked. It's caused security changes. I can see that the PR for the security approval is here. And if they've got permissions to view that particular repository, they can go in there and see it. But normally you would block it off so that only a security admin can see that. And they can see that security admin, that's who they're awaiting review from. Over in the security application security repository, there's this PR, and I know that this PR is actually the one that's been created as a result of this PR on the left. We can see here, if I do that, I can see that it's PR 100 on the security database, which is this one here. So what can the security admin see? He can see that, okay, somebody on the application code repository, and it's Mark Lawrence, he was the author of it, on pull request 17, which marries up with this here. They've made a change, which has resulted in a security delta. This PR is blocked because a code owner has to review it. So security admin has to approve this before it can go in. So let's have a look at the change. So here we can actually see what's gone on. We've got the baseline security metadata on the left. That's what was there before. And on the right is what's happened as a result of the automated testing on the application change on the left. And we can see that a command's been run. It's a system command, and the role group, someone that is a teller, is trying to get read access. Now, a security admin might think, that's a little bit dodgy. I don't think I like that. So what I'm actually going to do is I'm going to try and get the developer to think about it a little bit more and ask them, did you mean this? So we can start a review, and then we can finish the review and request changes. So keep in mind what's on the left-hand side. That security check is still in progress, right? It's awaiting approval. So on the right-hand side, the security admin is about to reject it. So changes have been requested. What's happened on the left-hand side? We've got immediate feedback. So it's failing. The security check's failed because the security reviewer has concerns. So developer can go in here and they can see, right, the security admin, which happened to be me, Mark Lawrence, he rejected it and said, please answer questions. Did you mean this? So the developers then got a couple of choices. They can either say, no, I didn't mean that. So what they could do is they could make a new commit on the pull request, which reverses the change, which would then cause a new commit and a whole new pipeline to run. So all of this, what you see here, all of this will be reran, including a new security check will be reran. And because that's happening, as a result of it, the pull request on the right for the security admin will be automatically closed. So the security admin doesn't have to worry about it anymore. If they did mean it, what they need to do is they need to liaise with the security admin and talk about it. And then if the security admin can be sufficiently satisfied that they do need it, then they can go in and they can change their review and actually say, oh, okay, actually, it's good. So if we monitor this we'll do this on the right. If we monitor what happens on the left, we should see that the check will update. There we go. So we didn't see because it didn't refresh in time, but essentially what did happen is that the security check passed. And as a result of both the application PR being fully approved and the right-hand side security PR being fully approved, that bot, which acts as the syncer between the two PRs, they've automatically merged the changes. So those changes are now being committed to the code base. And I can prove that by looking at the checks here. I can actually see, oh, right, okay, the security did get approved in the end. And we can say, all right, okay, well, Mark Lawrence, he did go in, he did approve it, and he did say, actually, it's good. So there's a demonstration of SDV. So I'm going to stop. Okay, stop the demo. I did mean to go over to my slides. So we've got about a minute to spare for questions if anybody had any.
There were a couple of questions on the chat, but I believe you've answered them as you went through, Mark.
Excellent, excellent demo. So if you have any questions, please feel free to post. I have a quick question on the SDV, this pipeline. So sometimes a program can be used among multiple transactions. How would that SDV tie in from that aspect?
For remote transactions?
No, for example, one business application and another business application can use the same program, which is changed. And the SDV comparison, is it based on the transaction, different transactions? What's the best practice, perhaps, I was after?
Shall I answer that, Mark?
Yeah, if you want, Colin, yeah.
Yeah, so what would happen on there, as Mark showed, you have the role that is involved for whatever application that you're running. if you've got two applications that share things, they may share roles, in which case the role name is appropriate. There may be different roles that you've got on the application. So what it's telling you on the SDV is this role needs access to this resource, and you can then use that and check in your security repository, does this role currently have access to this resource? And if not, then you do an RDFine or possibly just a permit to give access to the role for the resource.
Okay, thank you.
So,
thank you. There is a question on the chat. Is any special surrogate access required for running against other profiles?
this should all run without any security on the region, or as much security on the region as you want. So it's designed so that it can only needs sec equals yes and users to actually have user IDs. No other security is required, but dependent upon your environment, you can put as much security as you need onto your environment. So many people have transaction security and nothing else on a development environment. Some have not even that. Others have more. So it's whatever you like, but no special authorities need to run this program. The SDC, which obtains security definitions, only will obtain security definitions for the developer, rather than being able to see anybody else's security definitions. You can only see your own ones, and it also can be configured so that even the developer doesn't see it. It just goes to the security admin, as happens in the SDV.
Cool. Thank you. Okay. If there is no other questions, and thank you very much, Mark, as well as Colin, for answering the question for this great session. And please feel free to give feedback as well. And I look forward to see you in the next session.
Thanks, everyone.
Thank you. Bye.